Welcome to another video in the Spotlight series where we're looking at distributions you'll quite often use in your probabilistic sensitivity analyses. We're going to be looking at the chi-square distribution in this one, which you don't see very often, but I think can be quite useful. So the chi-square distribution I find is actually good for modeling rates. It has just one parameter called nu. It looks like a v, but it's called nu. Sometimes they use k instead of that. That's the degrees of freedom. And the chi-square distribution with nu degrees of freedom is just a sum of squares of nu standard normal variates. So if you take nu number of normally distributed random variables with mean 0 and standard deviation 1, and then you square them all and you add them, that will have the chi-square distribution with nu degrees of freedom. And you can see in this graph on the right what it looks like with 1, 3, or 5 degrees of freedom. As I mentioned, the chi-square distribution is useful for modeling rates. So if you imagine that you had your data, which was k events took place over a total exposure of t, then you can model the uncertainty distribution of the rate as x divided by 2t, where x is chi-squared distributed with 2k degrees of freedom. Okay, so just as an example, if we had 26 deaths from snake bites over 1 million person years of exposure, then we would use x divided by 2 million, where x is chi-squared distributed with 52 degrees of freedom. Okay, and here's what it looks like in Excel and in R. So in Excel, we've got this events and the exposure, so they're kind of the data that we're supplying. We'll calculate the degrees of freedom as being 2 times the number of events. The deterministic value for this rate is just the events divided by the exposure, as you can see here. For the probabilistic version, we're going to take that chi-squared dot inv, give it that random number between 0 and 1, and then the degrees of freedom. Remember, the degrees of freedom is 2 times the number of events, and then we're going to divide it by 2 times the exposure. And in R, you're just going to use R chi-squared, R CHISQ, give it the number of random variates you want it to produce, the degrees of freedom, remember you're doubling the number of events, and then divide it by the exposure, once again doubled. Great, that's the chi-squared distribution.